Number 1, the integral of 6 over the x squared plus 4x plus 3 dx. First thing you want to do when you see a fraction is look to see if you can factor the denominator. And in this case we can, into x plus 3 and x plus 1. So what we're trying to do is take this fraction, which we cannot integrate, and turn it into two smaller fractions. So we have 6 over x squared plus 4x plus 3 is equal to a over one of the factors, x plus 1, plus b over the other factor, x plus 3. In the next step, we need to rid ourselves of fractions. So we multiply by the common denominator, which is that factored form x plus 3x plus 1, on both sides of the equation. And that will then cancel out the denominators. So on the left, the denominator crosses out with the x plus 3 and x plus 1 to get 6. Now on the right, we have to distribute the x plus 3, x plus 1 into the two fractions. So in this illustration, you see that the x plus 1's cross out. So what it leaves is a times x plus 3. Then crossing out the x plus 3's, a is left with x plus 3, and b is left with x plus 1. And now we're going to take that 6 is equal to a times x plus 3 plus b times x plus 1 and find what a and b are. This process is called convenient values. I'm going to let x equal negative 3 because it's going to eliminate a. So we get 6 is equal to a times 0 plus b times putting negative 3 plus 1 near that b, you get negative 2, which leads you to 6 is equal to negative 2b, which implies that b is negative 3. Repeating that process, another convenient value would be x equals negative 1, because that will get rid of the b. So you get 6 is equal to a times negative 1 plus 3 is 2, plus again b times 0. This gives you 6 is equal to 2a, which implies that a is equal to 3. And we found both of our letters a and b. So at this point, we know that the integral of 6 over x squared plus 3x plus 2 must equal the integral of 3 over x plus 1 minus the integral of 3 over x plus 2. And in both these cases, it's going to be u substitution. So here I let u1 equal x plus 1 and u2 equal x plus 2 since they are different u's. And in both cases, the derivatives are dx. So this ends up being 3, the integral of 1 over u1 du1, minus 3 integral of 1 over u2 du2, again both being natural logs. So we get 3 natural log of the absolute value of u1 minus 3 natural log of the absolute value of u2, which turns out to be, back substituting, 3 natural logs of the absolute value of x plus 1 minus 3 natural logs of the absolute value of x plus 2 plus c.